Welcome back, Gary Simmons here for the Game Institute with a completely unplanned Lesson 42, AI Final Tweaks and Fixes. So let me tell you a little bit about the origins of this video and why I felt it was needed. So starting from the next lesson, we're going to begin implementing other systems, such as interactive environments, the ability to set tasks and missions that the player must complete in sequence in order to finish a level. But perhaps more importantly, we're going to begin the implementation of a robust audio solution that is going to cater for the demands that our final Dead Earth game is going to put on it. Now, I'm one of those developers, like I'm sure there are many of you out there, that often forgets about sound and thinks I'll put that in at the end. And when you find yourself in that situation, you always realize that adding the sound was nowhere near as simple as you thought it was going to be. You thought you might just have to drop a few audio sources in the scene and you'd be done. But of course, in a real game, we have many more requests for sounds to be played than the audio hardware can handle. So we need to come up with a robust solution that is going to allow hundreds of zombies to be requesting that they make sounds, but we only play the sounds that are the most important to the player at that particular time. But of course, there's other problems we need to solve as well. If I select AI Jill and her AI Entity Game Object and open the animator window, we are reminded that we have a multi-layered animator. And on each of those layers, we have states that describe what the zombie is doing. So it stands to reason that the way we're going to make footsteps sync up with their sounds is we're going to create curves in our animations, and we're going to have some scripts, some state machine behaviors on some of these states that describe exactly when a footstep sound should be made, for example. And that will make sure that it synchronizes perfectly with the foot hitting the ground in the animation. Problem we have though is that using a multi-layered animator, we know that if, for example, we put the lower body or the upper body weight up to 1, that's going to override all of the animation states on the base layer. And that's exactly what we want. However, if we have scripts on the base layer states that are triggering sounds, those scripts are still going to be executed even if the lower body layer's weight is 1. So what we're going to get is not only are we going to get 2 lots of sounds being triggered, those on the base layer and those on the lower body layer, and of course those on all of the other layers where we may have sound scripts on. But all of those sounds being played from the other layers are obviously not going to synchronize up in any way with anything that the animations are doing on the current layer that is controlling the character. So we're going to need to make a layered audio solution so that as layers activate and deactivate, we also activate and deactivate their sounds. But that's all for the next lesson. So let me tell you about this lesson. I thought it would be really fun if over the next few lessons we made things a bit more exciting, so that when we're developing our audio manager and we're developing our interaction scripts and our mission logic, we do so in the context of a little mini game using all of the knowledge that we have so far and the knowledge that we're going to accumulate over the next few videos. And I decided to create a little game called Creeper. Here it is. You can see it's even got a little title screen with a simple menu. And in Creeper, you play the part of an employee of some faceless corporation that has had its facility overrun by zombies. You've got a simple task. You need to escape the level in the elevator. And in fact, you can see you even start off in the elevator. That sounds pretty simple, right? We just go over to the keypad. Oh, but look, it says keypad no power. So we're going to have to go and find a power generator in this level, activate it to turn the power on. And in fact, we're going to have to do a load of other things as well. There's going to be several dead bodies spread throughout the level. One of them randomly is going to have the key code placed upon them. But even that's not all. We're also going to have to shut down or deactivate the lockdown procedures that's stopping anyone leaving the facility. So there's going to be basically sort of 3 tasks we have to achieve. We have to turn on the power generator. We have to find the dead body that has the access code on it so we know what key code to type into the elevator's keypad. But even that's not enough. We're going to have to find a computer once the power's been turned on, and we're going to have to deactivate the lockdown procedures. Then when we make it back to the elevator, we're going to be able to leave the level and our mission will be complete. So in Creeper, you're going to have very little in the way of weaponry. In fact, your only defense if a zombie gets hold of you is going to be pushing them away. And that's not going to be fatal to them in any way, but might just be enough for you to break loose and run away. We're also going to have limited health and stamina. So you can see I've created a very simple HUD here. And as we run, our stamina drops. So we can only do very limited time sprint bursts. That makes it a lot harder to complete this mission as well. Now, when the level starts off, the zombies are going to all be set to be very hungry, so they're going to be mostly feasting on dead bodies. And one of those dead bodies is going to have the key code on that you want. So the only way to really clear an area is if we press the right mouse button. We essentially taunt the zombies and make a noise that draws them over to where the player is standing. We lure them away from where we want to get to, and then of course we have to run away while all the zombies go and investigate the source of the sound, and hopefully we can creep around the back of them and swipe the access code from the security guard, or at least check if that's the security guard that's got the code on it, and that's basically how it's going to work, alright? So we've got the ability to push zombies away when they get hold of us, and the ability to make a noise to get their attention. Fortunately, our zombies are deliberately quite stupid, so it's not too hard to shake them off. As long as you duck and dive around a few corners, they won't really be able to extrapolate from the last place they saw or heard you where you might have gone. So that's how this game works. So what I decided to do after the last video is I thought I'd go away and quickly make Creeper, the prototype, just to check that we can make what we want to make with just the knowledge that I've shared with you so far, plus some of the things we're going to learn over the next few lessons. And when you do this, when you start using the code that we've written in a proper game environment, that's when you start to test it, and that's when a few bugs or glitches start to raise their head, which perhaps didn't show up when you were working with a single zombie in a small test environment. So I isolated a few of these problems and areas where I think it could be slightly improved, and this short video is just going to be about fixing up those little holes in our AI system before we move on with other things. So let's start looking at the first little bug that raised its head, which was just a silly little inspector assignment mistake that I did not notice last lesson. You will recall that in the last lesson, if I drill down into our prefabs folder, we created this AI sound emitter prefab, and it was this sound emitter that was supposed to be instantiated by our zombies whenever it screams, and by default it places the AI sound emitter at the last position that the zombie saw the player. It's set to auto destruct after 10 seconds, and of course after 10 seconds it's destroyed and then the zombies go on about their business. But while that emitter is active, all of the zombies within the radius of the emitter sphere collider come running to investigate what the source of the sound was. The idea of this prefab, of course, is that we select Zombie Jill and Zombie Butcher, all of our different zombies, select its AI entity game object, and in its AI zombie state machine, we drag and drop over the AI sound emitter prefab reference. Now, when I started creating Creeper, I found some very strange behavior, and that is after I'd been playing it for a while, I found that all of the zombies were just amassed in one location, just in their alerted states, and they wouldn't go anywhere. And it took me ages to find this problem because honestly, I didn't think I could possibly be as stupid as I'd been in the last lesson. If I click on the sound emitter, what should happen, of course, if I've got the project window active, is it should highlight the AI sound emitter, but it doesn't. It highlights the sound emitter of our FPS controller rig, okay? So all of our zombies aren't storing references to the AI sound emitter prefab. It's storing references to the FPS controller's sound emitter. And when we instantiate that, what we're really doing is when a zombie screams, it's creating a copy of the player's sound emitter in the scene, which does not have a destruction script on it. So of course, what was happening is the first time a zombie screamed in Creeper, this sound emitter would be created in the level, a copy of the player's sound emitter, and it would never be destroyed. So that sound just stayed there for the entire life of the game. Every time a zombie screamed, it would leave one of these emitters in the level, just constantly aggravating my zombies. And of course the zombies would run to investigate the sound and would just stay there investigating it because the sound would never stop. So of course what we need to do is select all of our zombie prefabs, and we need to make sure that they have references to the AI sound emitter instead. So of course what I need to do is open up all of my zombies. I'm going to open them all up. Hopefully I can do a multi-assignment on this, but I'm not so sure it's going to let me do that. Oh, I might be lucky. Let me select all my AI entities, like so. And now I can take that AI sound emitter prefab and drag and drop that into the Scream prefab slot. And then what I'm going to do, let me just select Zombie Jill's AI entity, scroll down, click on the AI sound emitter, and just check it's definitely selecting the prefab in our project view and not the player's sound emitter. And that is one problem solved. So what I'm going to do is I'm going to select now all of my zombies and apply all of those changes to the prefab. Oh joy, doesn't let me do that with a multi-select, so I'll have to do it with each one. Okay, so if you're following along, the project that I gave you at the end of the last lesson, which I'm sure you've downloaded to continue in this lesson, does have this problem. Now, I'm not going to fix this and re-upload the project, because otherwise what I'm talking about in this video will no longer have any significance. So this is a classic example where a stupid little assignment error can actually chew up about half an hour of your time placing debug log statements everywhere, trying to find out why the hell your zombies have all just stopped their patrol routes and are just hanging around in one location in the level. Okay, problem 1 solved. So the second problem I want to fix, I'm sad to say, is also one that I introduced at the end of the last lesson. You will recall that we didn't like the way that our character controller could run into a zombie and easily push that zombie out of its path. It made it ridiculously easy to simply plow into a whole pack of zombies and push them out of the way like Skittles or 10-pin bowling pins. The reason for this, of course, is because our zombies are being controlled by nav agents, and our character controller has a nav obstacle on it. Therefore, the navigation system will always do its best to try and steer our nav agents, our zombies, out of the path of a nav obstacle, our player. Therefore, as the navigation system has no control over our player, the nav obstacle, it can only move the agents out of the way of that obstacle as it moves, and that's what we were seeing. Now, you will remember that we got around this by basically detecting when our character's collider touched the zombies collider, and when it did, we simply killed the speed of our character down to a very small amount. If I call up my FPS controller rig, you will remember we called this 0 to 1 value the NPC stickiness value, where a value of 1 would kill the speed to 0, whereas a value of 0.5 would kill it to about half speed. In order for this to work, we had to do a few things. We first of all had to go to the edit menu, we had to go to the project settings submenu and call up the physics manager, and we had to make sure that our player layer, which is the layer that our character controller is on, is collidable with our AI entity layer, which is the layer that the capsule colliders of our actual zombies are on. Once we had done this, we could implement one of Unity's special functions in MonoBehavior called onCharacterControllerHit. Let's load up our FPS controller script to remind us of the function that we added to it. So I'm going to drill down into my scripts folder, my FPS controller folder, and I'm going to open up the FPS controller script in MonoDevelop. And if I scroll down to the very, very bottom of that class, you will see that this function onControllerColliderHit will be automatically called by Unity whenever a game object that has this script on it and has a character controller on it collides with another collider. And all we simply do is we test to see if the collider we've been past belongs to a zombie. Then we essentially reduce that drag multiplier based on our NPC stickiness. So if drag multiplier was 0, elsewhere in the FPS controller, drag multiplier gets multiplied by our final speed, and therefore we'd have a speed of 0, right? So that's how it works. Now, the problem that we've got, and I had completely forgotten that we had seen this behavior many, many videos ago, which is why I had initially disabled collisions between the player layer and the AI entity layer. So let me describe how this bug manifested itself. While I was testing Creeper, I often found myself surrounded with zombies, all of them attacking me. All of a sudden, I'd find myself launched up into the air and would find myself standing on the zombies' heads. And this was a case of deja vu for me, because I remember many videos ago we had actually seen this behavior, and that was why we had disabled collisions between the player layer and the AI entity layer to begin with, but I'd completely forgotten about it. So of course, what's happening is our character controller, which remember is not just the thing that moves and detects collisions, but is also our capsule collider. It has the job of moving our character or unembedding it in the case where it finds it's embedded in geometry or other solid objects. Our zombies, although they have capsule colliders on them, are not controlled by the physics system. They're controlled by the animation system. So our animators are going to always be making our zombies lunge forward when they're attacking the player. And of course, it's very possible that when a zombie is playing an attack animation, the root motion in the animation might drive the zombie forward and embed its collider in our character controller. And normally the character controller would resolve this by simply stepping back, moving us back a little bit so we're no longer embedded. However, when I found myself surrounded by a pack of zombies, there was actually no direction I could move, at least in the XZ plane, that would unembed me. I was completely surrounded by solid objects all attacking me, and many of those objects were playing animations that were forcing their colliders into me. The character controller had no choice. The only way it could unembed me from those objects and resolve the collision conflict was to essentially catapult my character straight up in the air, so I was now stood on their head. It treated the zombie as if it was a massive step. This is obviously not the behavior we want. So what we're going to do is not use the character controller to detect those collisions. In fact, we definitely want to make sure that the character controller and the zombie's AI entity layer are not generating collisions. So let's first of all turn that off. So I'm going to go to the edit menu, the project settings submenu, call up the physics manager. I'm going to make sure now that I untick that box we ticked in the last lesson, which says the AI entity should generate collisions with the player layer. I'm going to turn that off. So we don't want to use this function at all because we're not going to be using the character controller's collider in that way. What we're going to do instead is we're going to add a child trigger to our FPS controller rig. Now, the reason why I add a child game object for this is that you might be thinking, well, the character controller is a collider. There's nothing we can do about that to make it a trigger. But what we could do is add another trigger to this game object and handle it in there. But of course, we can't do that because that trigger will also be on the player layer because it's on the same game object. So what we need to do is create a child game object, which isn't on the player layer, but is on a layer that does generate collision messages with the AI entity layer. So what I'm going to do is I'm going to right click on my FPS controller rig and I'm going to create an empty child game object by choosing create empty. And I'm going to call this sticky detector. Then I'm going to add a capsule collider. I want to set the is trigger boolean to true. I want this to be a trigger. And I also want to put it on a layer that is going to generate collisions or trigger messages with the AI entity layer. And of course, we know what that is. If we open up Zombie Jill and open up a AI entity game object, we can see that the zombie itself is on the AI entity layer, but we have a target trigger. Now, just to remind you, the target trigger is the thing that detects when the zombie has reached its target. That is on the AI entity trigger layer. In other words, a layer that triggers when an AI entity has entered it. So that's the layer that we wish to use. So I'm going to select my sticky detector child game object in our FPS controller rig, and I'm going to set this to the AI entity trigger layer. Zoom in on my FPS controller now. I just need to see because that trigger that we've added is not even remotely in the shape or size that we want it to be. So what I'm going to do is select my controller rig, and I really just want to copy over the radius and the height. So it's 0.4 radius and a height of 1.8. I can't just copy and paste these values because one is a character controller and the other one is a capsule collider. So 0.4 and 1.8. So I'll set the height to 1.8 and the radius to 0.4 like so. So I'm going to go back to my FPS controller script. I'm going to just delete that function because that's no longer going to be of any use to us. It's no longer going to be called by Unity for any of the collisions that we want. And I'm going to create a public function with a void return type. And I'm just going to call this do stickiness. It takes no parameters like so. And the main core line of the function is going to be exactly the same, okay? So our child game object that we just added to our FPS controller rig will have a script on it. And when it detects that a zombie has entered its trigger, it's going to call the do stickiness function of the FPS controller to apply the drag to our character. So let's save that off. So back in the editor, in my FPS controller folder, I'm going to create a new C# script and I'm going to call this npc sticky detector, like so. Open it up in MonoDevelop. I'm going to get rid of the update function. I am going to keep the start function because I am going to need that. So this is just going to have one variable, which is going to be a reference to the FPS controller that exists somewhere in the hierarchy up above it. Remember that our NPC sticky detector script is actually going to live on our sticky detector game object, which is a child of the FPS controller rig. And what we're looking for is the FPS controller script that is essentially on its parent game object. So what we'll do is we'll create a variable of type FPS controller. It's private, we just need to store a reference to it, and we'll grab a reference to it in the start function by doing the following. We'll say controller equals, and I don't know whether we've used this before, but we're going to use the get component in parent function. So we're basically saying to Unity, we want you to step up the hierarchy instead of down into the children. We want you to step up into the parent chain and return the first FPS controller that you find. And we store a reference to that here. And obviously there will only ever be one FPS controller in the parent hierarchy anyway. So what we want to do now is write the onTriggerStay function, which remember will be called by Unity automatically whenever any collider collides with this trigger. So the first thing we want to do is check if the collider we've been passed is actually the collider of an AI state machine. You remember our game scene manager has this get AI state machine function for doing that. We pass in the instance ID of the collider we've been passed, and if it is indeed an AI state machine, it will pass us back a reference to the AI state machine script. Of course, if it's not an AI state machine, we want to completely ignore this collider. It's nothing that we're interested in. So we'll say, assuming we have a valid AI state machine and we have a valid controller, we're going to call that function that we just implemented. We're going to say controller.doStickiness, which remember is that function here, which pretty much does exactly what it did before. So all we're doing is exactly the same code that we did before, but we've sort of distributed it over two objects in a way. Go back to the editor, and what I need to do now is drag my NPC sticky detector script and put it on my sticky detector game object. There you go, no parameters to configure. It's as easy as that. So if I press play now, we should still get the same behavior, but we'll no longer have a situation where I find myself stood on the heads of other zombies. Okay, so there you go, it killed me stone dead. Now what you're seeing there, oops, yeah, there you go. So you can see they're all attacking me now, and I'm not being forced up to stand on people's heads, which is pretty cool. Okay, so we solved that problem. The third problem actually just highlighted itself when I ran that code here. It's not really a bug, it's just something I haven't implemented yet, and it was actually recently brought up on the GI forum. So it reminded me I do need to solve this problem, and that is, look what happens when I run into the back of that zombie. I'll turn my light off, okay, so that it's not the light that alerts him. Look, I've run into the back of the zombie. It doesn't even know I'm there. It just ignores me. And of course that's because our zombies threat system is all based on what they can see and what they can hear. So if we run into a zombie front facing, it's going to see us as a visual threat because we're going to be within its field of view. But if we run up behind the zombie and smack straight into its back, it's not going to know we're there at all. It's not even going to react. And that is obviously pretty stupid behavior that we need to fix. Fortunately, that is also easy to solve. So that's what we're going to solve next. So to make testing this a little easier, let me turn off all of my zombies except, I think I might, what's Citizen 1? Let me put that one on. That's cool. That's the one I wanted. Let's drag that dude out of there and let's spin him around so he's facing away in the opposite direction to the way that we're going to approach it. So if I press play now, oh actually what I'll do also, just so it doesn't walk off, is I'm going to select Citizen 1's AI entity, and it's going to start off in idle, and I'm going to adjust the idle state, and I'm just going to put the idle time up to 2000 seconds, okay, on both the min and the max, so I know this guy is not going to go anywhere until I've got up and tested running into his back. So I'm also going to call up the lighting window. Remember, if you haven't got the lighting tab open, you go to Window, Lighting and Settings in Unity 2017.2. And I'm going to just ramp up the ambient color so I can really see what I'm doing a lot better. Something really bright like that. So if I press play now, it's going to give me plenty of time. Oh, one other thing I'm going to do is I don't want my zombie being alerted by my sound emitter, because that would be an unfair test. He might turn around because he hears me running up to him, so I'm going to turn off the sound emitter's sphere collider, and I'm telling you I'm going to forget to put all this stuff back on afterwards. I just know I am. So if I press play now and run up to this dude, he shouldn't actually react when I walk into him. Look at that. Silly, isn't it? What a stupid thing. He's got no idea I'm there. So that's cool. That makes it easy for me to test this now. Okay, so how do we make our zombie react when we approach it from behind and collide with it? Well, fortunately, I can use my sticky detector script for this as well. Our AI state machines have a visual and audio threat structure that they maintain each frame when they're keeping track of what is their most important threat. So let me open up my AI state machine class just to remind us what that looks like. So here I am in AIStateMachine.cs, and if I scroll up to the top of the file, you're reminded of a support structure that we created called AI Target, which basically is just used to describe a target to our AI state machine. And it has members such as the target type, which is one of the AI target type enumeration, whether it's a waypoint, a visual player, a visual light, a visual food, or audio. And it also contains a reference to the collider in the case where the threat has a collider, the position that the threat was last registered at, the distance from the zombie to that threat, and time. Time is used for internal stuff. You'll remember we use this to track when was the last time that we last saw this target and how old the target is, but we don't really need to go over all that now. The thing that we do need to remind ourselves, though, is that our AI State Machine class actually maintains two public variables of type AI target called visual threat and audio threat. And you will remember that our individual states, each update, when they detect that certain threats have come into their triggers, they can register these threats as either an audio threat or a visual threat with the AI State Machine. So what's really cool about this is that because these are publicly accessible, any object in our world can contact this zombie and can override its current threat. So what that means is in our NPC sticky detector, we can, in the onTriggerStay function, override this. We can set this to what we want. And remember that the audio threat and visual threat, if you go down to the fixed update function, you're reminded that the state machine actually clears these every frame. Okay, so every frame we clear them, and then the individual states then push any threats that they care about into the visual and audio threat. So we can do the same thing. We can just override it while we're in the onTriggerStay function of our NPC sticky detector script. This will solve part of the problem, but not all of the problem. But let's do that first bit so we can see what we've got. So in our NPC sticky detector script, in our onTriggerStay function, and in the conditional where we've identified that we do have a collision with a zombie, we call the controller's do stickiness function, and then I'm going to set the visual threat of this state machine to the player. Now, just to remind you, the AI target structure does actually have a member function that makes it easy to set up. We can use, bear with me, the set function where we pass in the target type, the collider, the position of the threat, and the distance currently to the threat, and that just stores that all internally, and our AI state machine will go on using that as normal. And of course, when we call this function, we're going to set AI target type visual player, which of course is the most important threat and will take the priority of any other threats that may currently have set. So let's go back to our NPC sticky detector script and let's access the state machine, which remember we got from the game manager here based on the collider's instance ID. We're going to get its visual threat and we're going to set that to ourselves. So the first parameter is AI target type. So we'll set this to AI target type visual player. As the second parameter, we have to pass in a collider. Now, in the case of our player, our collider is actually our character controller. Unity's character controller component not only contains the actual capsule collider, if you like, that's bounding our player, but it's also derived from collider, so we can pass that as any parameter that expects a collider. Problem is, we don't currently have access to the character controller. Now, one way we could do that is we could, in our start function, also search for the character controller component. But I think what I'd rather do is have our FPS controller script expose a property that allows anything that contacts it to get its character controller, just a simple getter. Now, I don't think we have that at the moment, so let me just try that. Controller dot character, no, there is no character controller member. So let's now open up our FPS controller script. Here it is. And this stores a reference to the underlying character controller. So what we'll do is we'll just scroll down here where all our properties are defined and we'll create a public getter. So I'll create a public property that returns a character controller, and I'll just call this character controller with a little c. We'll give it just a getter. We never want anything to sort of set and override our character controller. So we'll just return our underlying private character controller variable, like so. So now I've added the ability for our FPS controller to return the character controller. I can go back to my NPC sticky detector script and I can say controller dot character controller. As the third parameter, we have to pass in the position of our player. So what we'll do is we'll get our FPS controller script, get its transform, and then we'll get its position that way. And then as the final parameter, we have to pass in the distance from our zombie to the controller's position. So we will say vector3.distance, and we just pass in the two position vectors here. So the first one will be the zombie state machine's transform.position, and the second vector will be our controller's transform.position. So what's going on there? I've got an error on do stickiness. Oh, that's because I've done my property wrong. I put one too many curly braces on the end there. Okay, so that was in the FPS controller. So there's the property we added that allows any object to get the character controller. And if I go back to my NPC sticky detector, we've now got rid of that error. So now when we collide with our zombie, we are applying stickiness to our player, and we are going to manually override what its current visual threat is. However, this isn't exactly what we want just yet. There are certain states that our zombie can be in, where if we just set the visual threat, because the angle between the direction the zombie is facing and the player is greater than our turn on spot threshold, that's going to force the zombie to drop down into the alerted state, seeking left or seeking right, and have it slowly sort of turn around to face us. So that might be what you want, but it's not really what I want, because if I run into the back of a zombie, I'm going to expect it to turn around pretty quick and kill me. So one way that we can accomplish that is not only can we override the visual threat, but we can force the zombie straight into a state of our choice, such as the attack state. Now we know that in the attack state, we're no longer using root rotation. In fact, we have a slurp speed control. It's basically the speed at which we rotate it on the spot. So if we force it into an attack state, even if we're behind it, that zombie is going to smoothly turn around, but very quickly, and immediately start attacking us because we forced it into an attack state. Problem is, at the moment, there's no way for us to override the state of a zombie. That's all decided internally by the system. So what we're going to need to do in our AI state machine base class is provide a method where any object in the world can contact that AI state machine and say, hey, I want to force you into this state. And this could be useful in a number of scenarios. Let's say, for example, you were making a fantasy game with magic, and all of your NPCs had a state on them called freeze, which just freezes them rigid on the spot. You could then create some sort of spell or perform some sort of task, and that could cause all of the NPCs to enter a freeze state and just freeze, allowing you to escape. That's why it's useful for other things that happen in the game, other events, to be able to override the state of NPC characters within a certain radius. So what we're going to do is we're going to open up our AI state machine class, and we're going to add a function, and I'm going to call this set state override. So open up our AI state machine class. Remember, that's the base class, not the AI zombie state machine class. And I'm going to scroll down to maybe just under the start function, above the get waypoint function, and I'm going to add this new function here. Okay, so this is going to be a public function with a void return type. It's called set state override, and it's going to take as a single parameter a member of the AI state type enumeration. And just to remind you, the members of the AI state type enumeration are things like none, idle, alerted, patrol, attack, feeding, pursuit, dead, and of course any other state types that you decide to add. Okay, so scrolling back down into our function, so the first thing we need to do is check whether the state we've been passed does actually exist on this game object. And you will recall that one of the first things our AI state machine does at startup is it looks at all of the AI states that are on its game object and compiles them in the states dictionary. If the state we've passed is in our states dictionary, it means that we have added this state to our game object, then we can change the state as requested. But the first thing we have to do is say if we currently have a state that we're in, we must let that state exit. So I'll say if current state doesn't equal null, then current state dot on exit state. Call its function, let it do any cleanup. Now the next thing we need to do is we need to fetch the state, the new state from our state dictionary. And we also need to set the current state type to the state enumeration that was passed. Okay, so we now have the current state object and we know what the current state type is. So all that's left to do now is call its onEnter function, and we have now forced the zombie into that state, cleanly clearing up the state it might have been in before. Now probably something else we should also do is just make sure that we're not already in the state that we've passed, because that's a bit silly, isn't it? So we'll also say if state doesn't equal current state type and the state that we've passed exists in the dictionary. Oops, let me get rid of the underscore. So of course, now we've exposed this function, we can go back to our NPC sticky detector script, and after we've set the visual threat, we can then say machine dot set state override, and we'll set this to AI state type dot attack. Okay, now I'm going to save that off, and hopefully this will all work as planned. Did I save off my state machine script? Yes, I did. Let's go back to the editor, check we haven't got any errors. Okay, so let's run up to this dude, and let's hope it doesn't just sit there like a moron when I walk into its back. There you go. No, it turned around and it attacked me immediately. That's pretty cool. Okay, let's shake it off again. Just check it again. Ooh. Okay, so I'm going to run into its back, bosh, and it's gone straight into me. So that's the third problem fixed. Of course, I will make this project available for download with all of the tweaks that I've done to it in this lesson. There's one more thing that I want to fix though, and that is the screen behavior that we added last week had a slight flaw in it. And what I found when I was playing Creeper is that we need to set a minimum time between screams, because you can't always tell when you're watching the zombies' behavior, but when they're attacking you and you're dodging left and right, they will often drop back into an alerted state for a frame or two just to sort of readjust their position or reacquire their target. And this can of course give them a chance to scream again. So what I found was, like, when I had a pack of zombies attacking me, like a lot of them were screaming because they were going in and out of alerted and attack state quite often, and that was giving them a chance to scream again. So I think what we want to do is say that when a zombie screams, it's really not going to scream for like another minute or two. So how are we going to implement that? Well, let me close down some of these windows that I no longer need, because I've got like loads of them open. And we know that the screaming functionality is in our AI zombie alerted script, okay? And if I go into the onUpdate function of my AI zombie state alerted script, you see right at the top we say if the visual threat is a player, and if the scream chance is larger than 0, then we're going to scream. So what we want to do is we want to change that to say we're only going to scream if scream chance is larger than 0 and the amount of time passed since the last time this zombie screamed is a certain duration. If that duration has elapsed, then we're going to scream again. So I'm going to add some new variables here to help me keep track of this. So the first one is going to be next scream, okay? And that is going to be used to store the next time that we are allowed to scream. So when our application starts, it's going to be 0. In other words, we're allowed to scream straight away. But when we scream, what we're going to do is we're going to get the current time, and then we're going to add on to the current time the duration that we wish to pass before we can scream again. So the next scream flow is always going to contain a time in the future such that when we reach that time we can scream again. And we're going to create another float here called scream frequency. Now I could make this an inspector assigned variable, but you know what? I'm not going to. If you want to, you can serialize this field, but I think 2 minutes, 120 seconds works just fine. So with those variables now in place, I'm going to scroll down to the onUpdate function again. I'm going to change that conditional now to say if scream chance is larger than 0 and if time.time, which remember this isn't delta time, this is going to give us the actual time since application startup, is larger than the next scream time. Now of course when the application starts, the next scream time is going to be 0, so this is always going to pass the very first time the zombie screams. But when we enter this code and we decide to scream, what we're going to do is calculate the new value of next scream. So we'll say next scream equals time.time plus whatever we set that scream frequency to, which was 120 seconds, okay? So that is all the bugs taken care of. So we actually fixed 4 problems in the end, right? We fixed an irrational screaming behavior where the zombie could just continually scream in very close succession. We also added some code and some functionality to our AI state machine such that we can override its current state, and we can also override its target. We could always do that, but now with the being able to override the state as well, it means that when we touched our zombie, it's immediately aware of our presence and immediately goes into attack mode. We also changed the way that the collision with the zombie works. We no longer handle that on the character controller game object with the character controller collider, but we created a child game object called Sticky Detector, and we handle it as a trigger response instead. And that way we don't get any embedded colliders causing our character controller to be launched up in the air to resolve the conflict. And of course, the other thing that we fixed from the previous project that I uploaded is that all of my zombies now correctly reference the AI sound emitter prefab instead of bogusly linking and making copies at runtime of the player's sound emitter. And that's it. I think that's this lesson done. In the next lesson, everything is going to be different. We're going to start working on our audio system, which I know sounds boring, but it's actually going to be really interesting. You're going to see what's involved actually in adding sound to our game, because I think a lot of people underestimate the difficulties involved in that. Thanks for listening, guys. I'll see you next time. Bye-bye now.